we go. All right, here's our first screencast. So, all right, hopefully this works out. I got a microphone, everything's all good. All right, so looking ahead, this week we will be doing 5.6 today and tomorrow. Wednesday you will have a formative. Thursday we will be doing actual section 4.6 out of your textbook, but it fits right in to where we want it to be for today, or for this unit, okay? And then Friday you'll have 5.7, which will be screencasted, and you'll just watch it in class then, and then have work time on Friday. Your test for this section is on the 11th of November. So November 11th, which is not this Friday, it's the following Friday. Remember that this Friday is the end of the quarter, so if you're missing anything, get it to me. What's up? This week, yes, there is a formative this week. Yes. Okay? All right, so section 5.6, finding rational zeros. Okay? That's the goal today. Now, if I were to have a function, f of x equals, give me something here. 2, let's go x to the 4th plus 25. 25x cubed plus what? Or minus, I don't care. Give me 3 more. Minus 4x squared plus 18x. No, let's go, how about minus 9? Okay? If I have that, and I say, find the rational zeros of that, probably not the easiest one to do, right? Because you can't group it, you can't factor it, it's not a difference of perfect squares, it's not a perfect cube, and all that fun stuff. Okay? My goal is by the end of the day today that you have enough information to figure this out. Okay? Figure out what those are. Okay, that's my goal. That's our goal today. All right? So we'll come back to that here in a minute. Okay? So the rational zero theorem is what we are going to be using. And the rational zero theorem says that if you have a function, then every rational zero, okay, now let's think back to rational. Rational in mathematics is kind of similar to fraction. Okay? So all the rational zeros are of the form P over Q. Okay? Where rational here, remember, is like fraction. So what types of numbers can you write in rational form? Anybody? Positive. All positive numbers can be written in rational form. What about negative numbers? What about 0? So all of those can be written in rational form. Okay? So if the rational zero theorem says that right now we had a function. Let's go back to our function. Oops, let me get all of these in here together, and we will group it. And yes, I want to group it, and then I want to copy it, and then I want to paste it, shrink, boom. There it is. Okay? So there's our big old function. What we're saying is, if I want to solve that for 0, okay, right now we've got an unlimited number of possible zeros, right? Dare I say infinite possibility of zeros. Okay? Let's narrow that down, and the way we narrow that down is by the rational zero theorem. Okay? So, suppose that we've got this function here, 2x squared plus whatever x plus 15. I don't care about the pluses, I don't care about the minuses right now. What you look at is you first look at the factors of 15. What are the factors of 15? 3 and 5 the only ones? One and 15. So my factors are really plus and minus 1, plus and minus 3, plus and minus 5, and plus and minus 15. Okay? So I have that many factors of 15. Okay? Now I look at the factors of 2. What are the factors of 2? Plus or minus 1, plus or minus 2. Okay? So to find all the zeros, right, all the rational zeros, I take all of the red numbers here and I divide them by the first green number. Well, plus or minus 1 dividing by positive or negative 1 is just going to keep it the same, right? So I have plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Right? Then I take all the red numbers and I divide them by the next green number. And I repeat that process until I'm all out of green numbers. Okay? So here then, it would be plus or minus 1/2, plus or minus 3/2, plus or minus 5/2, and plus or minus 15/2. So I've taken that infinite number of possible zeros and I've whittled it down to 16, which is a much nicer number to try and pick and choose from. Okay? If this function has a zero, a rational zero, it's somewhere in this list. Okay? It's somewhere in this list right here. If this function has a zero, it's in that list. Okay? Now, let's go to our function that we had just made before. Okay? So there's our function. Okay? You find me now the rational of all the possible rational zeros of that function. Okay? So, what do we do? What do I first look at? Go back up here. What do I first look at?
The factor of consistent term.
Constant? So where do I find the constant? At the end, right? Okay, so what number's at the end? -9. So what are the factors of -9? Plus or minus 1, plus or minus 3, plus or minus 9. Okay? Then what do I look at? I look at my lead coefficient. Okay? So what are the factors of 2? Plus or minus 1, plus or minus 2. Okay? So now I take all the red numbers and I do what with them? So I just basically rewrite the red numbers first, right? Okay. Then I do what? Put them all over the second one, right? So then it becomes plus or minus 1/2, plus or minus 3/2, and plus or minus 9/2. You know me, I gotta fix that. Okay. So those are all the possible rational zeros to our function right there. So again, we've taken an infinite amount of zeros and we've narrowed that field down to 12. Okay. Then from that 12 now, we can use synthetic division to find 1, or find 2, or find all. How many of them do we need to find in this one? There's at maximum 4 of them, right? Okay, but there could be 3, there could be 2, there could be 1, or there could be none. Okay, because it's going to either cross, you know what I mean, with our end behavior, it could not cross the x-axis. Okay, all right, with me? What do you got?
The first one, you put all the terms over 2. No, the first one.
The one that, above here?
You put all the terms over. Oh, wait, it's the top row. Never mind.
Yep.
Okay. That's it.
Red numbers over the first green, red numbers over the second green,
Okay.
red numbers over if there was a third green out here, if there was a fourth, if there was a fourth green, if there was a fifth green, however many green numbers there are, we take the red numbers and we divide them all by it. Okay? With me? All right. Go for it. You try it. And we're back. So we have factors of 8, right? That's my last number, so that's going to be 1, 2, 4, and 8, correct? Okay. Then I've got factors of 2, which are 1 and 2. You'll probably rarely hear me say the plus or minus part because I'm just going to assume that it's there. Okay? So then, my rational zeros are first ones, I write down plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. I write down the red numbers as is. Okay? Then 2 divided, or 1, excuse me, divided by 2 is 1/2. Okay? 2 divided by 2 is 1. I already got it. 4 divided by 2 is 2. I already got it. 8 divided by 2 is 4. I already got it. Okay? Now, hopefully, if we watch this screencast, you'll see a yellow circle around those when I was kind of pointing, because that, I think, is how it works out. So there are all of my rational zeros from this function. Next step now, again, I've taken that infinite amount, I've narrowed it down to 10. Now from that 10, I can hopefully find at most 3 out of that list. Okay. Some of them, sometimes I might only be able to find 1, and the rest might be imaginary. Okay. Some of them might be, one of them might be a double. Okay. Yeah. See, now you're seeing the only problem with this now with this screencast is now you get to see my emails. Anyways, okay. Some of them might be a double. Okay. So then that would be one where it has a turning point right on the x-axis. Okay. Because what we're finding here, remember that zeros are also roots. They're solutions. What else do we call them? Answers. I thought we had another one. Nope, zeros, roots, solutions, answers, right? But then if we change it and we put them in point form, then they become x-intercepts. Okay? And if we put them in function form, they become factors. Right? So what we're really solving, what we're finding the zeros of a function. Well, the zeros of a function are also the x-intercepts. Okay? The zeros of the function, if we wrote them as factors, become the factors if we put them back into function form. Okay? So I think it was last week or the week before, because last week was so short. If we remember, I think I was talking about bus stops. Okay? It depends on where you want to get off the bus as to where you're going. And in order to do that, you're going to have to read the directions. You're going to have to know the bus route to figure out where you're going to get off the bus. Gus. Okay? All right? Yes, ma'am.
So if those are like the zeros for it, why are there so many if like the 3 is how, you see what I'm trying to say?
So there's only three of them that we get, right? But then, so what you're asking is, why are there so many in this list right here, right? Okay? There's so many in that list because that's all the possibilities that it could be, okay? From that list, we're going to narrow that list down even more to just the actual zeros. And that's what we're actually going to do on this next slide, okay? Yep, you're one step ahead, sister. I love it, okay? So, now here in this particular one, this one we're saying find all the zeros. On the previous slide, we said list all the possible rational zeros. Again, it's a different bus stop. Okay? This list was just that. It was a list here in blue. This one says find all the zeros. So the first thing I'm going to start with finding all my potential zeros. Because right now, I've got an infinite amount of zeros to choose from. Okay? I don't want to be that infinite amount. I want to be much more narrow, much more refined. I want to be able to say it's part of this list. Okay? So, I need factors here of what number? Factors of 18. So that's going to be 1, 2, 3, 6, 9, and 18. Correct? Okay. So now, and then I need factors of 1, right? Right? So it's just 1, right? So do I even need to rewrite that? No. So here's my list. Here's my all the possible ones. So here's all my possible zeros. Okay? From that now, I get to do some picking and choosing. Okay? If you guys were old like me, there was a TV show on in the 70s called Hee Haw. And on Hee Haw, they did some picking and some grinning. So you guys be the pickers, and I'll be the grinners. It was Roy Clark and Buck Owens. And one of them was a picker, picking like strumming their guitar kind of a deal. And one of them was a grinner. He just smiled, nice and purty like. Okay? So you be the pickers, I'll be the grinners. So from the list, pick me a number. 18? Okay, so we picked 18. So now, here in step number 2, we are going to try to find one or more zeros. Okay? And to do that, we are going to use our new friend, synthetic division. Okay? So we chose 18. So I'm going to synthetically divide 18 into x cubed plus 2x squared minus 9x minus 18. And when I do that, what am I looking for? If 18 is a 0 to that function, what am I looking for? No remainder. So I should have nothing right there. I should have a big old 0 right there. Okay? Let's try it. Drop the 1 like it's hot. 18, that's 20, that's 360, that's going to be 351, and I'm not even going to attempt to multiply 18 times 351, because it's going to be a pretty big number. Anybody got a calculator out there? 6,318, which gives me 6,300. Not 0. So is 18 a 0? No. So this is not a 0. So I'm not even going to worry about it anymore. Okay? Let's pick another one. Let's try 1. Okay? Now for me, I usually start at the low end and work myself up to the high end, but you guys started on the high end, and that's just fine. Okay? So again, I'm looking for a 0 at the end. 1, 1, 3, 3, negative 6, negative 6, negative 24. Not a 0, right? Okay? All right. So, give me another one to pick. 3. Somebody said 3. Okay. 3 into 1, 2, negative 9, and negative 18. Okay. So, we get 1. 3 is 5. 15 is 6. 18 is 0. Ding, ding, ding. What do we have? We have a 0. So this is a 0. Which means, what then is the factor? X minus 3 is the factor. Okay? And that's going to come into play here now in step number 3. Step number 3 is you are going to rewrite f of x. Because now f of x is equal to x minus 3 times what? X squared plus 5x plus 6. Okay? From x squared plus 5x plus 6. Okay? We drop the degree by 1, rewrite it as is. Okay? Step 4 now. Step 4 says, can we factor it completely? So I'm looking at x squared plus 5x plus 6, and can I factor that some more? What does that factor to be? X plus 2 and x plus 3. So now I can solve for my zeros. So x minus 3 equals 0, x plus 2 equals 0, x plus 3 equals 0. So my zeros now become x equals 3, x equals negative 2, x equals negative 3. So my zeros are negative 2 and positive 3 and negative 3.
So your zeros are moving from your original list. You don't have to find.
All three of those were in my original list. Negative 2, positive 3, negative 3. All three of them were in my list.
So could you do it either way? Where you just like go up the list?
You could keep trying the synthetic way, yes. Okay? I'll show you a little different method here too in the next one. Wesley first.
I think I missed something. Why, when you synthetic divide, like, why is there a 6 in there? Because there's a 6 in the list.
Because we never tried 6.
It's using the fraction.
I went the right 1, 2, negative 9, and negative 18 come from the function. Come from up here. Yeah, those came from up here in the function.
That's just a coincidence.
Yep. 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 I see what you're saying. Good.
Wait.
Go ahead.
So what happens when your lead coefficient has more than 1 or 2 factors?
Then your list gets bigger.
So
Your original list of possible zeros gets bigger. But in the end, if we would have had here, if there would have been a number there, like let's say 6, then I would have had 1 and 2 and 3 and 6, right? So then this list right in here, this list would have been longer. I still would have only had 3 zeros, but my list to choose from would have been bigger, more for me to narrow down. Okay? All right? With me? All right, fantastic. So, on this one, okay? Now, actually, let me take a pause for the cause. Let me go back. Bus stops again, okay? So my bus stops would have been, here would have been, let's go purple with it. Here would have been my first stop. Okay? If it says give me the whole list, I would have stopped there. Okay? That's my list stop. Here would have been my second stop. That's my factor stop. And then down here is my third stop, which is my zeros stop. So same way as we had, same amount of stops as we had last week. 3 stops on our bus route. Okay? It just is a matter of where you're going. Okay? So, try this one. And we're back. I know you guys haven't gotten very far there, but I wanted to show you a shortcut. I forgot I was going to show you a shortcut on this one. So, factors of 18 again are 1, 2, 3, 6, 9, and 18. Factors of 1 are 1. So that's my list, right? Okay. So that's my list of all possibles. Okay? Now, we'll go in the case before. What if this were a big, big list? How could we figure out an easier way to do this list? Well, one thing that we can use, because we have the technology, is we could utilize a graphing calculator. And we can type in our function. Our function was x cubed minus 4x squared minus 15x plus 18. Oops, that's 118, not 18. Make sure I got it right. Hit enter, boom, there's my function. What am I looking for again? Looking for what? The zeros, which are also the x-intercepts. So this function should have 3 x-intercepts, right? Because we've got a cubic function. So here's one, and there's one. That narrowed my list of things to choose. -1, -2, -3. So let's try -3. +1. Let's try +1, 2, 3, 4, 5, and +6. So hopefully we can do that from that. Okay? So now when I'm trying these numbers here in step number 2, let's try -3 first. 1, -4, -15, and +18 are my function values. 1, -3, -7, +21, +6, because remember I add these, -18, 0. We got it, right? Okay. Now, I'm going to show you something different too. Because this function, if I were to write it out, f of x here now is x plus 3 times x squared minus 7x plus 6. This function right here might not be, like for instance, if we go back to our original one that we made up at the beginning of class, it might not be, after I find 1, 0, it still might be a cubic. That's not factorable by grouping or by all the other methods that we have. So we might have to continue on with synthetic division to find 2 zeros to help us out. Now I'm going to show you here how to do that. So I'm going to call this step 2.b. Okay? So I'm going to factor that one. I know that one of the other zeros in this function is at +1. But instead of using my original function, I'm going to use my new factor. With me? Okay. So now when I synthetically divide this in, I still get 0, right? So my first factor was from the -3, and that was my x plus 3. My second factor is from the 1, so that's going to be x minus 1. My third factor is going to come from there, and that's going to be x minus 6. So my f of x here is now x plus 3, that was my first one, x minus 1, and x minus 6. Which, if I factor this right here too, that would give me those two right there.
So you can do either or.
You can do either or. And sometimes later on this week, we're going to get into finding all the zeros of a 5th power. So you're going to have to do it that way to continue on.
Okay.
Okay, with me? And then now we got x plus 3 equals 0. So x equals negative 3. We got x minus 1 equals 0. So we get x equals 1. And we get x minus 6 equals 0. So x equals 6. So my zeros are negative 3, positive 1, and positive 6. Okay? Would be my zeros. However, back up here, it said in our function that we need to find all the factors of this cubic. So my answer here is stop number 2 in factored form, because I found all of my factors. Okay. Again, in red would be stop number 1. Give me the list of all potential zeros. What I have boxed is stop number 2. Find me the factors. What's in blue is finding the actual zeros. Okay? Handle? I want to say that your homework is right there. This homework will be due on Thursday. You can start it. You can do most of it. Okay? And then we would just have to tweak some stuff tomorrow. Okay? Yes, sir.
I won't be here Wednesday for the quiz.
So yeah, so it's 3 through 24 multiples of 3. Now, if you're looking on the It's Learning, there might be, I think the answer key is actually 3 through 42 multiples of 3, so just skip over those extra ones. Okay. All right? This concludes our very first screencast.